All right, class. In this video, we are going to be looking at what does it mean to estimate the mean, and then also what does it mean to estimate the standard deviation given just a histogram. Okay. So the real difference here is normally we would need the actual data to be able to calculate exactly what the mean is and exactly what the standard deviation is going to be from a case like this. But if all we have is the histogram, there is a way to get a really close estimate of what those actual values are. And so here's how you go about doing it. First thing is, so it's like we're going to be averaging here. So I look here and say, okay, so I have 5 values that are in between 0 and 10. Okay, so I'm going to say that, okay, I'm going to pick the value here to be 5. So it's like I'm just going to grab the middle of each of the histogram bars. So this is 15, this is 25, this is 35, this is 45. Okay, and let me keep track of that in a table. Okay, so if I have, I'll call these the midpoints. So the midpoints value 5, 15, 25, 35, 45. Okay, so anytime you're doing a problem like this, always start by grabbing those midpoint values of each of the bars on your histogram. Okay, and then I want to know, all right, well, how many, right? What is the frequency? How many values do I have within each of the bars? Well, in the first one, there are 5 values. Okay, and then I have 5 values again for 15. And then at the 25 mark, I have 20 values, right? This goes all the way up to 20. At the 35 mark, I have 15 values, right? And then last but not least, at the 45 mark, I'm back down to 5 values, okay? So it's like how many times? So it's like I have 5 45s, 15 35s, 20 25s, okay? And these numbers could represent anything, right? These numbers could represent, I don't know, how many donuts somebody eats in a month, or how often somebody takes a nap in a year. Whatever. These are just numbers, okay? So the very first thing that we need to do with something like this is, I mean, if I want to eventually end up at the standard deviation, I need to get the mean, okay? So to get the mean, and I'm not going to use an equal sign, I'm using this approximation because this is an approximation. I don't know, so I'm using this value of 5, and I'm saying that there are 5 things at a value of 5. I don't know where those 5 things are. You know, they may all be right here, and I don't have anything that's really big. So me saying that I have 5 things at a value of 5 may be an overestimate, or they could all be on the other side, and it could be an underestimate of what I have here, right? That's why this is an estimation and not an exact calculation. So normally when you take the mean, you would add up everything you have and divide by the total. So I mean, you can almost think of this as a weighted average where you say, okay, at the value of 5, I have 5 objects at the value of 5. Then plus, at the value of 15, I have 5 objects at that value. Plus, at the value of 25, I have 20 objects. Plus, at the value of 35, I have 15 objects. Plus, at the value of 45, I have 5 objects. Okay, so, right, these are my red numbers. These are those frequencies. This is how many of the things that I have. So I have 5 times 5, I have 5 times 15, I have 20 times 25, okay? So that's going to give me a total, and then I would divide that by the total number of things there are, and in this case, this adds up to 50, okay? Get your calculators out, run the numbers in really carefully. When you do, you end up with 27 as an estimate of the mean, okay? So that's kind of a nice and clean number, and it's something that we can definitely work with. So now let's do the standard deviation, okay? So I'm just really quickly going to copy my table. So I have frequencies, and I have midpoints. So there were 5 5s, there were 5 15s, there were 20 25s, 15 35s, and 5 45s. All right, so let's get an estimate for the standard deviation. Okay, so again, S for standard deviation, and we're doing an estimate. So for this, right, your normal standard deviation equation looks like this, right? It's the square root of, it's the square root, oh, I can use my finger to erase this. It's the square root of the sum of the x's minus the mean quantity squared divided by n minus 1. Okay, so essentially we need to recreate this from this little table I have. And so you'll see how this works, right? So I'm going to just ignore the square root for right now, and let's just kind of build this. So I have my value, okay? So what's at the midpoint? My value minus the mean, and right, we calculated the mean to be 27, okay? Quantity squared, and I have to have that square because it makes the result of whatever's in there come out positive. And then I want to ask myself, okay, well, how many of those things do I have? Well, I have 5 of those things. So whatever that answer is, I'm going to multiply by 5. Just so you can kind of see like where the numbers are going, right? This is the thing minus the mean. This is the number of times that thing occurs, right? So you can kind of see where those numbers are coming from. So now let's kind of finish walking through this. And it's a sum. So then I'm going to add to that the next thing. And in the next thing, I have 15 is the value minus 27, quantity squared, and then I have 5 of those. Here, I'll do that in red. I have 5 of those. Sorry, that's a 5. Then plus the next one, so that's going to be 25 minus 27, quantity squared, and I have 20 of those. Plus, now I'm running out of room on my screen, but this is going to be 35 minus 27, quantity squared, and I have 15 of those. Oops, I guess I'm doing those in red. 15 of those, then plus the last one, which is 45 minus 27, quantity squared, and I have 5 of these as well. So let's see how this all plays out. And what we're going to do is whatever this value is, right? You start order of operations, so you start inside the parentheses, you do the parentheses in each one, then you square whatever the value is, then you multiply by the red number on the outside, and then you add everything up, okay? Then once you've done that, there's a division operation in here, so whatever that value is, we're going to divide it by. Now here's the difference. If this is for a population, and you know that these values, well, okay, in normal standard deviation, if you know that this is for a population, you would just divide by n. If you're doing a sample, you divide by n minus 1. And then I'm going to divide by n minus 1 here anyways, just because I already know that this is an estimate. And this minus 1 is a way to correct for error, okay? So whatever that value is, I'm going to divide that by n minus 1. This ends up clunking out to, if you get your calculator out and run all those numbers, and by the way, the n here is 50, right? So you're dividing by 49. You're going to get 118.3673. Okay. Now we're not quite at this would be the variance, right? If I stopped right here, this is s squared. You'd be looking at an estimated variance, but that's not exactly what we want. So then to finish off and to get the actual standard deviation, square root, so S is an approximation of the square root of 118.36, and that ends up coming down to 10.9 as a standard deviation for this data set that you have. So to kind of recap, going back here, right? Here's our distribution. We grabbed the middles. We found out how many things there were at each midpoint. We calculated an estimated mean first, okay? And then we used that estimated mean here to calculate the standard deviation. And we actually calculated the variance along the way, right? This 118 is the variance. Although variance is a little bit useful, it's not as useful as a number, in my opinion, as the standard deviation. So you take the square root of it, and you're back here with a standard deviation that we could then use. Anyway, so that's how this works. You're gonna follow the exact same steps with any histogram that you're working with or any estimation that you're trying to do. Grab the middle, find out how many there are, and then you walk through the calculations almost just like normal. If you have any more questions about this, let me know, and good luck. Thanks, everybody. Bye.